Hello, it's Mrs. Baxter, and today we are going to switch gears a little bit and talk about the rules for exponents. Hopefully this is a review for you, but one thing to note is this table that we're going to work through today is very important. So you will want to use this as a reference when you do your homework that's going to be given today, and then also would be great for quiz or test assessments. So make sure that you keep this worksheet handy because it will help you with the rest of this unit. Okay, so with exponents, one thing to note is that exponents are when we have something like this, we have a letter with an exponent up in the upper right corner of that variable. So down below right here, you're going to see something like with this adding and subtracting monomials right here. We're going to start here, and then we know how to do this. All we're going to do when we add and subtract, so I want you to do a little bit of write yourself little notes, add, subtract here, okay? You're just going to combine like terms. Now, if you've had me and you remember Freiburger, we cannot have those. We can't have combined Cokes, fries, and burgers unless they are exactly the same. We can combine Cokes, we can combine fries, we can combine burgers, but we can't make up something new, okay, when we're adding or subtracting. So let's look at some examples. If I'm looking at 9x squared y minus 10x squared y, make sure, okay, I'm seeing I have an x squared here, I have an x squared here. Yep, I have a y here, y here. So the numbers don't have to be the same, but our variables, they do. These have to be the same in order for us to combine them together. It's almost like saying I have 9 cats and I'm going to take away 10 cats. Okay. And with subtraction, remember, you have to go from left to right. So we are going to say 9 minus 10, which leaves us with negative 1 x squared y. Now, if you want to shorten it, you do not need to put a negative 1, and you could just write negative x squared y, okay? That is the same thing. All right, and then when you're looking at number 2, it says subtract 6w from 8w. So we're not subtracting 8w from 6w, even though your 6w comes first in the sentence. We have to think about the semantics and the meaning of this. And so we're taking away, which is what subtract means, taking away 6w from 8w. So really what we're doing is 8w minus 6w, which is equal to 2w. Okay. All right. So those are some examples of things that hopefully you recall that we have seen before. All right. Now let's look at the product rule. And I want to make sure that you write product is, let's write multiply. Okay, that's what product means. We are multiplying exponents, okay? Now, you'll notice it says x raised to the 8th power times x raised to the b power. You'll notice a and b are not the same, okay? So when we're multiplying, those exponents do not have to be the same like they do when we're adding and subtracting, all right? But the rule is here, when we are multiplying, we are going to do x a plus b. You're just going to add those two numbers together, okay? So let's go over to our example here. If I'm looking at h squared times h to the 6th, I'm just going to add 2 plus 6 together, and I'm going to get h to the 8th, okay? Now, let's look at example 2. It's a little bit more complicated. But always remember, you're going to start with your number first, or your coefficient first, okay? So we're going to start with our negative 2, and we're going to multiply times 7, okay? Because even though we're noticing this, it says negative 2a squared b times 7a cubed b. Remember, those two variables and the terms do not have to be the same. We're multiplying. All right, so negative 2 times 7 is negative 14. And then I'm just going to work my way from left to right. I'm going to compare my a's. If I add my a's together, what do you think we get? If you said 5, you would be correct. And then we're going to do B. How many B's do we have now? If I add them together, I have 1B plus 2B's is this. All right, so here is my answer for example number 2. All right, let's look at a different rule, the power rule. Now, the power rule is when we have something and we raise it to the other power. So you'll notice right here, we've got like an exponent to an exponent. All right, I've got A, but it's raised to the B power. All right, so remember that your rule is always going to look something like this. It's going to be X. Oops, that's not what I want. Right here, we're going to have X raised to the A, right? And to the B. That's your power exponent rule. Okay, so when you have XA raised to the B, you are going to go XA times B now. Because really what we're saying, let's see, is we're saying, say for example, X squared. What does that mean? Well, that means X times X, right? But if we're raising that to the, say, third power, that means I'm saying X times X times X times X times X times X, okay? And if I were to multiply those together, I would get X to the 6th, right? Because now I have 6 X's multiplied together, okay? All right, so let's look at an example. Oh, I guess I just did the example. Haha, look at that. So we know X squared raised to the third power is X to the 6th. Cool. All right, now when we're looking at example number 2, you're going to want to make sure you solve one term first before you move on to the other, okay? So let's do -2m to the 5th raised to the 2nd power. Well, don't forget, you still have to raise this also to the 2nd power because it is in that parentheses, all right? So -2 times -2 is +4. And then if we do our power rule, we are going to multiply 5 times 2, and we get 4m to the 10th, okay? After we get that, now we can multiply our m to the 3rd. Well, hey, guess what? We have to go back to this rule right here, the product rule where we're multiplying now. And so for multiplying, we're really going to add those two together. So when we add them together, we're going to get 4m to the 13th. Okay, so this is going to be the answer for example number 2. Now, if you ever get to a part of this where you get confused and you're not quite sure what is going on, please stop the video, come find me. Send me an email, ask me a question, okay? Because these letters can get a little confusing, but I think as long as you follow the rules right here, this is definitely going to help you on this worksheet. All right, now quotient, what does that look like? Well, if I'm looking at the example right here, quotient is the same thing as divide. So write yourself a note here. This is the divide rule. Okay, and when we're dividing, if you'll notice, when we multiplied, we added the two exponents together. We added a plus b. So what do you think we might do with divide? Well, if you said we're going to subtract them, you would be correct. We're just going to go xa minus b. Okay, so you're going to look at a, you're going to look at b, and you're going to subtract them. All right, let's look at our examples here. So if I have a number and an exponent or a variable with an exponent, always remember, you're going to solve your numbers first, okay? So if you were to plug in 27 divided by 42, you're going to get a decimal. So remember that math function where you can simplify your fraction in your graphing calculator. If you were to do that, it would give you 9 over 14. Okay, so we've simplified that. But now, what does our x look like? Well, we're going to go 5 minus 1, and that gives us x to the 4th. Okay, this is our answer for example number 1. Now, looking at example number 2. All right, what do we need to do first? Well, if you said, oh, whoa, simplify the top first, you would be correct. So let's make sure we do that. Let's simplify the top. Well, looking at our power rule up here, okay, our power rule, you'll notice, well, we need to multiply our outside exponent with our inside exponent, which gives us y to the fourth, okay? Y squared times, or raised to the second power is y to the fourth, and now we have y to the fourth over y to the fourth. Well, there's two ways you can look at this. Y to the fourth divided by y to the fourth, any number divided by itself is 1, right? So let's look at that and just do this. We're kind of getting ahead of ourselves a little bit. So this is y to the 1. And you're probably going to say, oh, but wait, if I subtract it, I got 4 minus 4. It's the same as y to the 0, right? All right, well, let's skip down a little bit. Do you see one that says 0 exponent rule? The very last one here is our 0 exponent rule. Look what happens when we have x to the 0 right here. Let me highlight x to the 0 right here. This is our exponent rule. Guess what? That equals 1. So if you're looking back at our original here, oh, Leo, stop. Here you hear my puppy. Hold on a second. He just had to tell me somebody's coming by. Okay, so then you'll notice y to the 0, this makes absolute sense. We have 1. All right, let's kind of go back before we get into our 0 exponent rule examples and look at the negative exponent rule. All right, so negative means just like what you think it is x raised to the negative a in this example. And when you see this, you are going to follow this rule. You are going to create the reciprocal, which means you're just going to flip it. So write yourself a little note, flip, okay? And you're going to have 1 over x to the a. All right. All right. So let's look at example number 1. Example 1 says negative 5x raised to the negative 2. Now, something that's really important that I want to make sure I mention is that this negative 5 is not associated or tied to this exponent. This exponent only belongs to the x. Okay. Now, when you look at example 2 up here, right here where it says y squared raised to the second, if you had a number right here, for example, you would include it because it is within a parentheses. But because this does not have parentheses, this negative 2 only applies to the x. So in this case, we're going to keep it negative 5, but now look what happens. Our x goes underneath and becomes positive and is a 2. Okay? So this is our answer for the first example. Okay, let's look at the second example. Well, the first thing I want to do is I'm going to simplify this. So I know that 4 divided by 8 is the same as 1/2. Well, if we're also looking at k to the second divided by k to the fifth, I'm hoping you're saying, oh, well, that's the same as k2 minus 5. Okay, if we look back at our quotient rule right here, and we're subtracting, and then now thinking about how we subtract, well, 2 minus 5 is negative 3. So I have 1/2 k to the negative 3, which is the same as this right here. Okay, so we're just going to create 1/2, but we're going to put our k, we're going to flip it, and we're going to change our cube, our third, to a positive. This is the answer for number 2. Hopefully that made sense. If not, please come find me. All right, let's go back down to our 0 exponent rule. This is the last rule that you need to know. X to the 0 equals 1. So hopefully when you're looking at this first one, you're saying, okay, this right here is equal to 1. So I really have 7 times 1 equals 7. That's our answer. Ta-da! Super simple. And then again, kind of going back to our power rule, we have to simplify the top. W to the fourth raised to the second power is the same thing as W to the eighth. And we know from our example above that this is the same as 8 minus 8, which equals W to the 0, which is equal to 1. All right, That is our final example. All right, so go ahead, get started with the homework. If you have questions, let me know.